All right. Very good evening to everyone. We are just starting in 2-3 minutes. I think we have around 15 participants. I'm expecting around 20, 21. Hi, Heather. Nice to see you too. We'll just start in just a couple of minutes. So I hope my voice and video both are clear. Great. Thank you, Heather, for confirming. Great. Okay, so let's start. I'll try that I'll be covering almost everything which I have planned within the time. So let me just sit. Yeah. So once again, good evening, everyone. This is quite late in India now. Hopefully, everyone, I think people have joined across different places. So welcome to this particular long-awaited session. First of all, I must apologize that I've postponed this particular session for twice due to some unavoidable reasons. I'm very sorry for that because people have registered for March 7th session, but I had to postpone it to today. So anyhow, in India we say "Der hai durust hai." So anyways, so let's start with the thing. So this is the session on the iFogsim, and we are going to have an introduction, and it's quite uh, interesting in terms of implementation of the IoT related things, right? So I'll be discussing about some of the very specific things, and they are like I'll be introducing you to the basic fog computing concept and how it is differ from the basic cloud computing, and how iFogsim is going to have its simulated version, and how the different models have been generated within that. Then we'll be looking into the essentials to start with the iFogsim, and we'll be looking at different set of project components which are there in this particular iFogsim API. Then we'll be getting inside of the project and going to look at the various models which are there, and the different components which are going to facilitate the simulation process. And then at the end we'll be looking at the example which are explained which is going to be explained in terms of that how the actual simulation process can be done from the scratch if you want to implement your own work, right? So if you are first time joining me with any webinars, so just to introduce, I think I've not stated my name. So my name is Anupinder Singh. I've been teaching engineering students for past 9 years, more than 9 years in fact. I have been supporting researchers who are working around the cloud sim or its extension tools, for implementing their um, research hypothesis, basically. So they can test by utilizing the simulation tool, and I give them some consultancy or help them to work around with tools. Apart from this, I also have couple of courses out there on Udemy and as well as on superwitsacademy.online. So let's start with the very first thing, because we have been coming from the cloud computing domain, and we have extensively discussed about cloud sim and its related components. So generally, what is the basic purpose of using the cloud computing is to keeping the centralized form of computing and its relevant resources. So uh, at if you look at this particular diagram, what you see is, or this image is that you have different kind of devices, right? So your smartphone, your laptop, your servers, your tablet, your network, your other mobile devices or databases, they all are being actually be served through some kind of cloud-based resources, right? And who are going to provide you these cloud-based resources? There will be some kind of public or private service provider who is actually going to maintain all these resources for you, and you're going to pay for using those particular set of features or resources that are there on the cloud computing, right? So every individual request or every individual task that you wanted to do on your individual devices which are connected to the cloud, they are going to be served through the resources which are present on the cloud service provider, right? So when I say cloud service provider, so we know there are a couple of big giants: AWS, Google, Azure, right, Rackspace, and so on, right? So there are a couple of service providers. So they give you services corresponding to storage. They give you services corresponding to servers. They give you service corresponding to maintaining your databases, applications, containers, and so on. Right. So the primary purpose here is in the cloud computing is the centralized computing resources, and all the requests are being sent to the cloud, and then the responses are being sent back after the processing of that particular system. Right. And when we go toward the philosophy of fog computing, which is basically primarily been influenced by the Internet of Things, because a lot of different kind of devices has popped up which are recording the data and which are supposed to be processed, right? So what exactly happens is that fog computing is going to bring in a kind of architecture where the use of edge devices is there to carry out the substantial amount of your computation, storage, and the communications are to be done locally as well as to the remote resources which are supposed to be sent through the internet backbone. So just to look at that, what exactly this could look like is something like this: that you have some cloud, but there is additional layer which has been added within that particular system, which is called as fog, and that is being further connected with the devices. Now these devices, the representation here is a very small, right? You can see some smartphones, your vehicular based resources, your own computer system, or some kind of components which are installed in your building, some kind of specific desktop or server based, not exactly server based, some kind of processing based mechanism, and that is being connected to one more layer, which is kind of an intermediate layer, and that intermediate layer is going to be present between this particular no this particular communication backbone which goes toward the cloud as well as the end devices, right? So we add on one more layer, right? So that is what this particular text is saying, that the fog computing is an architecture that uses edge devices to carry out a substantial amount of computation, We are saying computation, right? And the storage is also provided, and some kind of communication is happening locally. So when we say locally, so that means something is going to happen within that particular system, right? So this is the substantial addition to what the base architecture of cloud computing is there, right? So why the need is there? The very first thing we need to understand is that the internet backbone on which we are working, or on which we are sending the data, is basically coming from IPv4 setup, right? And we know what sort of devices are there. Even though if you look at the upgradation of the resources or the components on that particular backbone, it's still very slow in comparison to what the exponential growth in its utilization is happening, right? So the reason people have started moving for IPv6, and how the transition has started happening around 5 6 years back, which is still happening, which is still not completed. So it is still happening, and a lot of work is done corresponding to it. Why? Because we are expecting billions of devices to be connecting through this particular endpoint, right? So these are just only the representation, example representation for such kind of devices. There are billions of devices we're expecting, and those billions of devices, if they start sending the data towards a cloud for their processing, that becomes a very tedious job. One is the congestion is going to get increased, and second more important part is, even though we say the cloud has a endless has infinite resources, but they are not infinite. So it is supposed to treat, or it is supposed to give an abstraction that represents the infinite computation resources available to the service provider, but they also has to manage some kind of scheduling or resource allocation policies, right? So that is the primary reason why the fog computing and the edge computing, most of the time they are being used vice versa, but they have their own set of properties associated with them. So when we talk about fog computing, this is what primarily you should consider or visualize in your mind, that there is an additional layer of computation which is going to be present between the cloud and the end resources. Now the end devices are not going to send the request directly to the cloud. They are going to have some intermediary, which also has a capability of computation and having some storage capability for maybe temporarily, but they can support that particular part. So from the very first concept of this fog computing is actually came from the Cisco, and they actually coined this term to support the IoT network through their network infrastructure. So what the objectives were at that point of time is to analyze the most time sensitive data at the network edge, close to where it is generated, instead of sending vast amount of IoT data to the cloud. Now if I give you the example, the time sensitivity. So let's say we are managing a network within a particular hospital, right? And some patient requires the higher amount of oxygen as what they are maintaining right now, and we are is presuming that the flow of the oxygen is maintained automatically depending upon what the condition of the patient is, right? So let's say some patient requires the higher flow of oxygen, and the time sensitive the decision is supposed to be done in a time sensitive manner, right? So you cannot send the request to the cloud if, let's say, there is a congestion and the delay happened, and all because of that delay, if the patient dies, then what is the use of deploying that particular automated system? So there is supposed to be some kind of you know computation which should be available either at the immediate component which is analyzing that particular oxygen flow, or something which is closer to that particular device which can be deployed within that building, instead of sending the request towards the cloud at that point of time. That local device which is present in the building, which is doing the computation for that particular set of patients, should be able to do the computation and increase the flow of oxygen to that particular patient. So this is something which is just a presumed example, right? There are endless possibilities in terms of your traffic management, in terms of your air traffic controllers, in terms of your fire services and all that stuff. So that's the very first objective they were looking at. Second is act on IoT data in milliseconds based on the policy, right? So that means the another part they are trying to look at is the policy, right? It is basically with respect to the resources. It is basically with respect to the scheduling of a particular set of tasks. If there are multiple tasks are to be done through a particular computation device, right? And the last objective is sends the selected data to the cloud for historical analysis and the long-term storage. So they haven't neglected the presence of cloud, but they have considered that okay, by the time the computation is required for the real-time sensitive data, that can be done locally or maybe a level up or two level up, but not directly to the cloud, right? And the analysis for the analysis and long-term storage purposes, once the processing is being done, that data can be sent back to the cloud, right? So that's the primary thing they have considered, right? So that this is what is there considered in terms of your fog computing concept, right? And that's not only that we are saying it's fog, we are also considering the term of edge as well, right? So what is the basic difference in fog and edge that we can understand from the prospect that edge, when we are talking about edge computing, then we are considering that the device which is actually sensing the data, right? The device which is actually sensing the data, they have their own capability of computation, storage, and possibility of implementing the policies related to the communication as well as the scheduling of the resources and the task within them, right? And if it is not possible for by that particular device, then it should be able to send it across to the level up, which can be considered as a which is basically a fog set of node, which can be a router, which can be a system which is connected to that particular router for giving the computation resources to that underlying layer of edge devices, or it can be some kind of no, specific sub cloud facility, right, which is going to be within your ISP and so on. So there can be endless, and there can be different kind of possibilities that we are considering for the fog node. So edge will have the minimal set of resources, right? The very minimal set of resources. Fog will have more higher set of resources from the edge, and the cloud will definitely have the most of the capabilities of the computation and all, right? And why this particular infrastructure or architecture is being popularized, because at every individual level where the network or communication has been maintained, the load is reduced. The load of bandwidth is reduced because the processing is being done within the architecture at different levels, right? So if we talk about this particular set of devices, right, they might not have the enough capability, but they can send the request to the fog nodes, and the computation is done over here instead of sending the things to directly to the cloud. Whereas for, let's say, this particular device, we are considering that there is no computation available, it directly sends to the fog node. And even if the fog node is not having, it is going to send it across to the cloud. So the minimum requests are going to cloud, and maximum requests are going to be solved through the fog layer itself, right? So if we look at the number of devices that we are considering billions of devices at the edge, millions of devices at the fog, and thousands of devices at the particular data centers, right? So that is what is the philosophy behind these two set of terms, right? And In fact, there has been one of the very specific architecture, the software stack, or you can say the service stack, which has been maintained or published for this particular set of computing architecture, that is under the open fog stack, right? So this is something which is being published through this open fog community, and you can simply see what exactly is there in this particular stack. So we can simply see there are five different kind of services which are there: the performance and scale, security, manageability, data analytics and control, IT business, and cross fog application. These services are provided across the stack, right? So whichever the place you are or whichever the component you are, it none of the matter, you are actually going to have all these particular implementation at all the individual levels of this particular stack. At the bottom of this particular stack, you will find the sensor, actuator, and the actual physical resources which are there. Above this, the protocol and the protocol abstraction layer is going to be maintained so that uh, the uh, the infrastructure can be correspondingly managed or subscribed as towards these particular set of resources, right? Now, because they are also supposed to have some kind of no, resources associated with them, because we are supposed to give them abstraction, so compute, storage, some kind of GPU related stuff, and the network, they are supposed to be provided to these particular underlying infrastructure platforms, right? And then security is supposed to be done, and the node management is supposed to be done. So we are when we are considering multiple nodes at a particular layer, then we are supposed to have that management stuff corresponding to those set of nodes, right? So you cannot neglect that particular part. And then specifically hardware virtualization is supposed to be done because you are going to deploy the applications uh, to these nodes, right? And once we have all those stuff in a particular individual node, we are supposed to have certain backbone corresponding to that particular node management and the software backbone. And then over the above, the application stack is being maintained, that is under two different things. One is this application support and one is the application services. So this is something in already in picture, already in implementation under the open fog consortium. And you can treat it as a standardization for a particular implementation process, because at the end of the day, there will be a number of providers for the fog based computation or fog based implementation in the actual real world environment. So making the system portable, they require to have some kind of stack, and this is what is going to be there. You can presume this certainly equivalent to what we have studied in our no uh, networking subject, that is OSI models or TCP/IP stack, right? So you can compare it to them in terms of, if you are doing some kind of comparison in terms of what is the standardization, or what is the cross platform implementations is to be considered when you are having different proprietors being involved into implementation of the particular infrastructure, right? So this is the real world thing. But why we are here in this particular webinar, we are here to discuss about the simulator, that why the simulator is supposed to be used, right? Because we are researchers, right? We cannot go and implement all these kind of devices in the real world. Even if we go and try to build up the test bed, it is going to cost us a lot, right? It is going to cost us a lot in terms of money, in terms of hassle, in terms of maintenance of the complete architecture and the system and so on. So it's very difficult that to generate that test bed and the human resource that you require to maintain that particular part. And as an individual researcher, it's not possible for you. So generally, simulators. Why the simulators are required for the research? Because the real system exhibit varying demand, supply pattern, and system size and resources. Right? If I go on the Cisco network, or if I go on the AWS IoT based network, it will be very difficult for me to spend money first and send then asking them to implement my policies corresponding to the testing or benchmarking process, right? So it's not possible for me. Next is because in real-time environment, users have the heterogeneous, dynamic, and competing QoS requirements, right? So you cannot test anything in repeated manners. So that's another issue, and that's why the simulator is required to be done. So application have varying performance, workload, and dynamic application scaling requirements. That is also supposed to be considered. And one of the most important thing, due to the third party ownership, no flexibility on configuration and cost. Even if you go and ask them for research prospect, they will give you some kind of voucher of $100, $200, maximum $500, but you cannot have the complete control on all those things. And in fact, you will not be able to configure to the lower level configurations, right? You will only be able to do the high level configurations, maybe set up some set of devices and the corresponding end nodes, and then you try to make communication between them, and using only the policies which are available in their system, right? You will not be able to do your own work. So that's the biggest challenge. And the most important, reproducing the reliable results and benchmarking is extremely difficult in these real time systems. So the simulator is very, very important. So that is why the iFogsim is being uh, developed. And in fact, it's the extension of Cloud Sim, and they have worked upon in a similar manner as the Cloud Sim entities are being working around. So we'll be looking into all those things in just a couple of minutes. So just before getting on to the real code, I just wanted to highlight some of the features why that iFogsim simulator should be used. So one is hassle-free extensible modeling and event-based simulation of large-scale IoT infrastructure that is there, right? Then we have self-contained platform for modeling the sensors, the very important thing, the actuators, which is going to, you know, uh, actuate on the basis of what we are going to process from the sensors in terms of data. Then for fog nodes are going to be there, n number of fog nodes you can extend. Then service brokers and the implementation policies, apart from that, provisioning and allocation policies are there, which you can implement. By default, there are a few which are being implemented, and they you can extend them as per your requirement, because they have given you the abstract classes as well. And then simulation of network connection among the simulated system elements. One thing you should always note, if you're already working with iFogsim or CloudSim, you know that the simulation is happening and everything is being calculated by using some mathematical models, right? So simulation is basically the calculations only, right? Producing the behavior by using those mathematical models. So the network connections which are going to be simulated among the elements is again going to do some kind of mathematical calculations, and then they are going to produce results to you, right? And then support for the cloud as well as fog only computing. That is where this simulator brings in its USP, right? So you can have both of those things together, right? Then these are some of the essential things that you should have for starting with the iFogsim. So you should have JDK 1.6 or above, because the iFogsim is basically been developed over the CloudSim 3.0.3 version. So JDK 1.6 or above, and when I say above, it should not be above 1.9, because couple of time people install all the latest either the open JDK or Oracle's JDK, but 1.9 is the maximum version which supports about it. So if you are big fan of Eclipse, you can go for 4.2 or above. Minimum 4.2 should be there, or alternatively, if you are big fan of NetBeans, it's up to you. You can go for the NetBeans. For today's webinar, I have been working in Eclipse, so I will be demonstrating using Eclipse itself. So let me just close this. Great. So next thing is the iFogsim architecture. Before I actually go and drill down into the code, I wanted to discuss about this, that how the iFogsim architecture has been designed, and this diagram is actually been taken from the core paper of the iFogsim. I hope you guys have gone through that particular paper. So this is the paper which is there. Uh, for the iFogsim. The iFogsim, a toolkit for modeling and simulation of resource management techniques in the Internet of Things, Edge, and Fog Computing environment. This is a beautiful paper from Harshit Gupta and his team. Basically, he's been mentored by Rajkumar Bhaiya, and this chap has actually worked upon a lot of different uh, set of models which are there within this particular system. So he is the one. The project is also hosted on his Git project. So I'll be going through all those things, but I just wanted to mention this paper that we are that this is one that you should be referring if you are just starting up with the thing, and even if you have already started working and then you are doing some pretty good stuff in the system of iFogsim simulator, still you should go and reread this paper. Every time you read this paper, you're going to get to have some new things. And in fact, you should also be looking into the cloud sim if you get time. Anyway, so let's start with the architecture. So we can see there are a couple of layers which have been there. I'm going to discuss bottom up, right? So the very first thing which you see at the bottom is the IoT sensor and actuator, right? So these are the set of devices which are going to represent or model or simulate the actual real life devices which are either collecting the data, right? Or on the basis of that collected data, when the processing happens, the some kind of output is supposed to be done correspondingly. So there are devices who are going to produce that output. So if I take an example, let's say we are working on let's say we have an exam we have a particular use case where on the basis of temperature we are going to actuate some sort of shades which are going to be deployed on the rooftop, right? So if we are considering that particular part and that particular case, what is going to happen is the temperature, if let's say the temperature rises beyond the 30 degrees Celsius, that means the sun is going to be very hot in that particular case. So at that point of time, the shade should be deployed, and in the evening, when the sensor is going to sense some reducing the temperature, the shade should be uh, removed or should be collapsed in that particular. So this is a very simple use case which you can consider, or maybe if you can consider some use case which is corresponding to the hospital environment, that is also there, right? Like the example which I took for the oxygen flow for a particular patient. So sensors and the actuators are going to work corresponding to that particular model part. So this layer is going to have the implementation for those set of things. By default, there are two particular classes, sensor.java and actuator.java. These two classes are being there in the iFogsim. If you want to have a customized kind of class, then you can actually go and the extend consider extending the cloud sim thing, right? So overall, uh, what you can consider is that this layer is going to have the implementation for your particular set of you know, uh, end devices that are going to be reaching out to the users, right, or connecting to directly to the users. Then there comes the fog devices, right? So fog devices are the one which are going to be there for the computation part in the intermediate layer. Okay, so that is what is going to be representing, and in fact it is also going to represent the cloud. Now depending upon a flag, this device is going to represent either the cloud or the intermediate node or the switch or something like that. Then there is a layer which is data generated, right? So data streams are going to be maintained correspondingly. So when you say data generated, so generally it is being generated through the tuples or I should mention that one thing I should mention before mentioning the tuples is that the communication or the data generation can happen between the sensor and the application, and the applications and the application, or the fog devices, or between the fog devices, right? So whatever the data is generated, right, that data is labeled that for which particular set of devices it is being generated, so that data stream is going to be maintained. Then because everything is happening through the network, right, so when we are talking about everything is happening through the network, then they are supposed to be monitored, right? You have to optimize it for certain kind of performance, and then you generate the knowledge base. In fact, if you go and read the paper very carefully, they say the knowledge base support is going to be in the future. It's not exactly implemented, but they have given a provision which is going to refer to the knowledge base in the future implementation, which I believe is not going to happen because the project is not at all active in last 2 years. If you look at the project page, the last update was hardly I think January 2020. uh, we'll see into that when was the last update when we go to the project page. Then there is a resource management. So when we say resource management, it is supposed to be done through the brokers only. So not only fog devices are present within the system, there are fog brokers as well, right? So they are going to have the scheduling of your tasks, and they are going to take care of the resource provisioning and the operator placements, right? So right now the resource provisioning is something which is going to be available in the iFogsim, and the scheduling is available. Operator placement is not directly available in the system. Then because we are considering the application deployments on the different devices, right? So when I say application deployment, it is a distributed application we are talking about, right? So there are two models of the application which are being implemented into the iFogsim. One is the sense, process, and actuate, which is involving the data generated from the raw data generated from the sensors, which is going to be processed by the fog devices, and then on the basis of that processing, the actuator is going to actuate. That means it is going to do some functionality after that, right? So this is where the different layers of devices, different layers and devices are being involved. Whereas another one is the stream processing. The stream processing basically happens between the application modules. This is not like that some sensor is going to generate the tuple. It is the stream, it is the application module which is going to generate the tuple, and they talk to each other uh, in terms of that sharing of data, right? So it's more or less distributed processing which is going to happen in that particular application model, right? So that is what we are considering. And top of the thing is the IoT application. So this is basically resembling your set of no type of modules that you can deploy on different fog devices, based on what sort of processing you want for that particular or what nature of processing you want from that particular application, right? So every individual research hypothesis is basically belongs to a different idea, right? So there are three different scenarios which are being uh, explained in this paper, and they are pretty good. So I think Mukhtar was asking about the title of the paper. So you just simply go and find for iFogsim a toolkit for modeling, and type in the Harshit Gupta's name in Google Scholar, and you will find this paper, which is in collaboration with Dr. Rajkumar Bhaiya, right? So you can go through this particular one. So there are three different scenarios which they have implemented. One sample scenario they have already displayed over here. That is here, this one, right? So this particular the system resembles that there is a public cloud and there is a private cloud which has been represented over here, which is basically resembling the fog layer basically, right? And there are certain node devices which is switch and edge, and then they are connected to the edge correspondingly, right? So this is what is there in this particular paper. And apart from this, if you go and go to the bottom of this particular paper, you will find that they have explained the particular app case studies, right? corresponding to the online game, which is basically corresponding to the VR. I think the example is with the VR game kind of thing. And then they have another case study for intelligence surveillance, and the last case study which is there is, I think, third one. So they have in okay, so they have displayed only two case studies here, but the examples were three. So we'll be looking into all those things, but everything is been explained very beautifully in this particular paper. So if you are seriously considering the iFogsim, then you should be, actually you should actually go and look into this particular paper. So when we are looking at this particular architecture, I just wanted to, give you an idea. The thought just came in my mind that how exactly the system works within this particular part is. So here at the edge, we are considering the sensor and we are considering the actuator, right? At the fog node, we are considering a fog device and we are considering a fog broker. Okay. And the cloud, again, we have a fog device, but for this, the cloud flag is basically enabled, right? So that is what's the difference here. And correspondingly, what we have application, right? And that application is further having some modules which are basically divided across these fog nodes. So maybe M1, M2, M3, M4, something like this. And all these modules are connected to each other, or are maybe connected to the sensors by use of some app edges. We call them edge or app edge, right? And there is one more thing which we are going to discuss once we go into the project, right? So this is what you should be, visualizing when we are talking about the edge, or we are talking about the fog, and we are talking about the cloud layer, right? So sensor and actuator at the bottom part, then fog device and fog broker at the, middle part, and then cloud is also a fog device, but with the cloud flag enabled. And over these particular layers, over these two layers, the application modules are being deployed and they are being connected through the app edges, right? So that's the primary visualized kind of thing, because generally when we go and look into the code, we are not able to actually visualize that, okay, which thing is going to be residing at what particular layer. So that is why I just wanted to mention it into this particular place, right? So let's get into the project, right? So starting with the very first thing, I think I should be considering taking you to the very first part. I think I can search it for you. So iFogsim, GitHub, right? So this is the place where we can actually go and look into it. So the very first link which has been shown to my particular system is this, right? So here you can see Cloudbus, Clouds Lab, iFogsim. This is the toolkit where you are going to be utilizing your project, right? I'm sorry, I should not say your project. It's a project from the Clouds Lab. So here it just defines some set of instructions, right? That how you can actually go and configure this particular part. But simply what you should do is you should go to the code and you should download the zip file, right? So that's the direct considered part. Okay, so is it not visible? I think I have shared only the presentation. I'm very sorry. Oh. Is it visible now? I hope it should. Great. So sometime it happens. So what I did is I simply did iFogsim GitHub. I just searched for it. And then I went to this very first link, that is clouds lab oblique iFogsim, right? And then once we go to this particular project page, you can see what is at this particular part, right? So we have some couple of folders here. So one is topology, src, result, output, jar. Apart from that, there are two files which are specific to GitHub. So you can see 5 years ago they have been implemented. There are 13 branches which are being there for this particular project. So you can see the last implementation was done 5 years ago by the Harshit Gupta, right? This is the person who has actually worked on this particular project, and this is the project which it has on his own GitHub repository page, right? Or so these are the two places I think which you should be looking into for the iFogsim, right? Let me take you back to the project page again. If you wanted to switch between the branches, you can go from here. If you are aware about the Git, I think there is no need to explain it. If you are not aware, then you should be now looking into this, right? So master is what is being considered the current code, but I also insist people to go and look into this improved branch, right? IMPROV. This is the branch which has been worked upon by the Harshit Gupta, no, some time back. So you can simply see what is the difference, right? The previous project page has the output, has the implementation done 5 years ago, right? But there are two other folders in this improved branch where the Harshit Gupta has actually worked upon on the improvement of the code, but it has not been merged into the master branch. I don't know why. uh, and this is one of the biggest drawback, I would say. When people start working around this particular project, they get confused with a couple of things, right? So this is one thing which I have actually mentioned in my course as well, which is basically I have essential of sim tutorials, right? Apart from this, there are two tags, v 2.0 and v 2.0. So there are two. So whenever you are downloading the branch or downloading the latest project, you should be downloading from the v 2.0, right? So that is again the another thing which I should be pointing out in this particular webinar, so that you should be working around with the things. Abdul, wait till the last of the webinar. I'll let you know. Then, if you wanted to see that does this project is active or not, you can look into the insights. Right? I always insist people or researcher to fork this repository and then start working on that, right? Because that could bring you another implementation, right? So if you fork this repository and take it to your own GitHub page and make that repository a private repository, you can work it around. Once your work is done, your paper is accepted, you should make this particular repository available to the to the you know to the public. And before that, when you are trying to publish your work, you should be sharing that particular repository link with that paper email, right? Or with that paper remarks when you are submitting it, right? So this is very, very important in case if you want to have an accelerated review of your work, because people look at that authenticity of your particular project, right? So that you can work on your own. There are certain issues which people basically uh, submit to the project team, right? So if you are facing some kind of bug, then you should be looking into this particular section. This is very important. A lot of time people spend a lot of their efforts in some sort of error which they are facing, but that error was actually coming because of the bug which is available in which is present in that particular project. So in case if you are finding a weird output or finding a weird behavior of your project, you should be at least looking into these particular set of issues, so that you should get to know that what could be the probable fix corresponding to that particular system, right? So generally they respond to the issues if their team is working around that particular part. So this is what I wanted to tell you about this particular project page, because a lot of people just directly go and download this particular zip file, right? And once they have this particular zip file on their machine, they unzip it and then they configure the project uh, into the Eclipse, and then they start working on it. But you should be looking around different branches. If your requirement is fulfilled through that particular branch, you should be selecting that branch and do the download zip, and then you will find that there is a difference in the set of code which is there. Okay, so this is very important if you are just starting up with this particular project. Setting up the project is very easy. You simply go to the file, go to the new, go to the Java project, right? Once you go to the Java project, you can simply do, let's say, ifog March 13. Okay, and then I think I should be first looking into this particular this one. Show in the folder. I'll go and pick this up. Go to my other drive. Let's say I go into March 13 and then go here. So simply I can go and look into that. Okay, what folder is here? Great. So right click, extract here. So it takes some time. Okay, great. So I have this thing available with me, and then I can go back. Instead of use default location, I can simply browse to that particular location. So I've just copy pasted. You can go on browse as well if you want, right? And then click on next. And you can simply see what other things are available. I think everything is fine. Yeah, so I click on finish. And you can simply see that I have my system configured over here. That's it. This is how you can configure your iFogsim. Then you go to source code and go to this GUI example. Go to fog GUI, right click on this and run as Java application. So this is what you get. So if you get this, that means everything is fine. Your project is configured properly, right? This GUI is basically for generating your own topology, right? So that's why this GUI is there. Otherwise, if you have gone through a couple of videos, they are of no use, because the output which is being displayed for this particular topology actually comes through the cloud analyst, which is missing in this particular system. I did not find any of that particular thing. I tried to work it around, but it is not available. So don't go on those set of videos. I think they are not they are kind of misleading you. They might be from the old branch. I could not able to find that particular branch, but only the topology which you wanted to generate can be generated from this. So let's say you wanted to have these are the icons. So this is for sensor, this is for actuator, this is for fog device, this is for their link between the devices, this is for just to open the existing topology, and this is to save. So let me create one model for you, which is basically the model based on, let me tell you, uh, I think this one. So which is going to be based on the sense, process, and actuate, right? So I can go for some name, let's say S1, type sensor. So basically this is just a name which has been given. So we are going to have a normal distribution here, mean 2, standard deviation 1. This is purely depending upon what is your own requirement. Oh, things didn't work. S type sensor, distribution uniform, minimum 1, maximum 2. Oops, something is happening, I think. S1, they have node, but I think I need to stop it for a while. This is sometime it happens when you are doing live. Otherwise, the project runs fine. Anyways, I just simply close this project. I go back to the other one and go to the example. Go to this geo. And let's try it here. Sensor SS1. Sensor distribution uniform, minimum, maximum. Okay, so mind blowing. I never thought it is going to happen on the live. So fog level 1, upload bandwidth 1 or 2, MIPS, let's say 100, 512, MIPS, rate MIPS 250. Oh, so I think I missed one thing. I need to build up fog first and then the sensor will be generated. That's my mistake. Then the edge is supposed to be created between them. So S1 and fog latency is supposed, this is basically milliseconds, MS. So you have this node connected to other one. And then you have an actuator, let's say A1, and type is, let's say, roof shade. Right? And then you have to build up the connection A1 and the latency is 1, right? So you can have a different latency corresponding to them. So if you want to save, I think I can do the save at this particular place. So within topology, I'm just going to copy this and paste it here. And then I give it a name. Let's say test March 13. So once I save it, and if I close this particular thing, and then if I come back to this particular project, oops, I actually did that in other one. Okay, properties, this was here. So I just need to copy that topologies, test March 1 to here. Great. So here we have to refresh. And you can see I have this test March 13 over here. Now, if we look into this particular file, generally what happens is whenever we are creating these topologies are saved as a JSON file. Okay. So if you try to open these files, right, and if I do the, formatting, let me go back and do this .json. Right, so once you have these files, and let me refresh it again. So you can see they are actually, now why I actually saved it as JSON, so that my Eclipse should be able to recognize it. So you can simply see the nodes which it has created, right? So nodes basically going to contain what are the different components that you have created. So we have actually created a fog component, right? We have given the name to that. We have created a particular sensor. We have created an actuator, right? So in whatever the sequence we have created, the same sequence has been maintained over here, right? And then we have actually created the link between those three devices. So they are being provided under this particular link section. Okay. So I think somebody's Java file working, but it cannot show any topology in MacBook. Please suggest any solution. So Mit, I think you have to rename it as JSON if you are using Eclipse, right? So nodes are basically going to have these set of information as a JSON file, as a JSON format, and similar is for the link, right? So you specify the latency. Now, what this latency is going to work for you? This latency is going to work for you in terms of that whenever these two devices or these two components are going to talk to each other, then what is the time that should be added during that particular mathematical calculation, which is going to be resembling the delay which should be happening over the network in that particular situation, right? So this is what is your particular set of topology. So if we look at the other topology, let's say DCNS game, so you can see there are a couple of nodes they have created. So one, you can simply see how many number of actuators they have created. So they have created actually two actuators. If you look at the fog devices, there are two fog devices. In fact, a number of actuators are more. So one actuator, two actuator, three, and then four. Okay, so there are four actuators. Then if you talk about fog devices, one, two, three, four, and so on. I think we can open this particular fog component, right? So let me show you how we can open this particular part. So this is here. So let me run that particular source file again. This is quite interesting tool, but you have to actually be very patient on understanding that how the processing is happening and what are the different components that are going to be working around. So let me open that particular topology for you. So the topology is DCN game topo. So this is how it is. It actually looks like. So it has one cloud. There is one ISP gateway, right? There is one. Let me just expand it. One camera node which we are considering. There is one. There are basically one, two, three, four camera nodes which we are considering as a fog node. That means they have the compute capacity with them. Then they have area gateway, right? Two area gateways they have created for themselves, right? And then there is a ISP gateway. So that means 1, 2, and 3 gateways are present in this particular topology, and there is one cloud. So when we are looking at these gateways, they are basically going to, whenever they're going to receive some tuple to process, they will just forward it to the next gateway. That's the primary component. I think all the queries and questions we can take at the end. Otherwise, it becomes a distraction for me while explaining the system, right? So here, if we look at the videos, right? If we look at these cameras, so they are basically doing a camera video, and then correspondingly they are going to do some kind of control related thing, right? So PTZ control they are some doing, right? So this component has been this topology has been already explained in that particular scenario one, I believe, one or two. So you can go through that in the paper. So this is how you can actually generate the topology. So whenever somebody asks me that, okay, how shall I be generating the topology for my hypothesis or for my problem statement, then I always suggest that, okay, just go to the GUI, generate the system as per whatever you wanted to have, and then save that topology, right? So once you save that topology, you have that file available with you, right? And once that file is available, you can actually utilize or you can actually read this particular JSON file. You can actually read this particular JSON file and create the topology within your examples or your example scenario, right? So where is the example scenario if you wanted to see it? So it has been available in the org.fog.test.prefab, right? So these DCN fog, this is where the JSON can be uh, you know processed, right? So this example is generating the devices by themselves, right? So if you see create fog device is a fog device is basically the function within this. Then add areas is another function here in this, and add camera is another function which they have created, and creating a simple fog device is another function within this, right? So what they have done is, for creating the area, right? So if you remember, we have two area gateways, right? So for creating the two area gateways, they have actually created this set of function for creating the general fog devices, that is the camera fog, not camera, the cloud and the proxy server. That means the ISP gateway and the cloud, they have used this particular function, and for creating the cameras, you can see they have created this particular set of they use this particular set of function. So they have actually generated these three functions correspondingly to generate that particular topology corresponding to each level, right? Whereas if you look at this particular function, which is get node function, which they have already commented, so you can see they have actually extracted the file, right? And that topology is being extracted, and then the function is being created correspondingly to generate that particular sensor and the other network, right? So that is how the things can be worked around if you wanted to have the JSON file read and then create the topology out of it into the example, right? So this is what is the beauty of generating that particular topology. And because as a human being, we are quite comfortable with the visual thing. Once we know that how my topology is visible, or how my topology is going to be configured, then I'm actually able to do the visualization on that, how the communication is going to happen in between those layers, those set of intermediate layers which are going to be there into the system, right? So that's very important for anyone who is into research, right? So if you can visualize the overall process, you can actually go and work around with the things. So this is what is here. So the project structure which is being configured over here is basically from the master branch of the project, which is on the cloud slab uh, you know GitHub repository. So we should be able to first understand, if I'm a beginner, I should be able to understand that, okay, what is the structure of this particular project, so that I should be able to work around it. So briefly, if you look at the basic structure, so we have JRE system library. So this is basically a support from your Eclipse function ID itself. Then we have reference libraries. This is again from the Eclipse ID itself. Then there is a SRC folder. This contains all the code, right? All the basic code which is there. I'll be coming on to this SRC in just a few seconds. Then there is a jar. So these are all the supportive files which are required to run this particular project. Then this is the output folder, where the output, which once you run your particular example, the output is going to be can be exported to this particular place, right? The result can also be exported to this particular place once you run your particular set of example. And then there are topologies which are being saved. You can save it anywhere, but by default they have given this particular folder, and you can extract it from here itself. Then last is the readme.md. So that's the simple file which is basically from the project page itself, right? So that's the only thing which we have. So let's go to the SRC folder, right? So that's very important to understand first. So once you go to the SRC folder, you will find a lot of different kind of packages. So if you look at from this package to this package, they are being imported from the CloudSim itself. So if you are well aware of the CloudSim based system, so these are the packages which are being imported from here, from CloudSim directly. And these packages are basically going to give you the simulation engine, right? So all the iFogsim related system or models which are being going to get simulated, they are going to run over this particular simulation engine. Then from this place to this particular package, right? These packages are basically being drawn from the SDN, so that network support can be provided to the iFogsim, right? So if you know about these two projects of Cloud Slab, one is the basic Cloud Sim and another one is the Cloud Sim SDN, then uh, moving on to the iFogsim is a cakewalk for you, because you know all the underlying implementations. Now from org.fog.applications to this particular part, right? So they are all packages which are actually being drawn for the iFogsim. So they are being builded from the scratch to support the fog components right? Which are there into this in this particular simulator. So starting from the core one, right? So I should be, telling you what are the core ones. So if I give you an idea, what is the core components? So they are basically the entities, right? So these are the core components which you should be looking into. One is the fog device, fog broker, sensor, actuator, end device, switch, link, and controller. Okay. So what are these? So let me take you to the entities. I'm going to org.fog.entities. Once I open this, you will find all those components over here except the controller. I'll take you to that controller in just some time. So all those couple of devices which are supposed to be there in the real world IoT based system or fog based system, you will be finding them over here. They are basically programmed model for all those things. So let me take you to the uh, fog device. That's the very important part. So if we look at the fog device, the very first thing you should be noticing that this fog device is a class which has been extended from the power data center. So this power data center is basically the class of classic cloud sim project, which is 3.0.3 from 0.3 I'm sorry, 3.0.3 version. Right. So speaking for more than 1 hour, it happens. So then if you go and look into this particular code, you will be able to see that there are north tuple queue, south tuple queue. So that means we are considering that anything which goes up in the layer is basically north tuple queue, and anything which goes down in the layer as a data stream is the south tuple queue. Then how many active applications are there, is what is the map that is going to be there within the application. App to module map is also going to be there, child to latency map is going to be provided, and so on. So there are a lot of different kind of attributes which are being provided over here, and they are required for maintaining the uh, real time situation when of this particular fog device component at the time of simulation, right? So they all are the basic different attributes which are being there. And then once you go and initiate once you go and look into the constructor of this particular class, then you will be able to appreciate, I'm sorry, you will be able to appreciate that there are different kind of parameters which are being passed on to this particular constructor from the calling class, right? So or from the calling scenario, right? So how do I know which scenarios are calling it? So that you can just simply choose this particular class, right click and go on open call hierarchy, and you will be able to see from where they are being called. One is from the util, that is fog entity factory. One is from the pre-fill DCN fog class. One is from the two apps class, and one is from the VR game fog. So they all are basically the examples which are being there in the particular this particular API or this particular package, right? So DCN is going to actually give a call to this particular this particular device, right? So let me open that one for you. So if you see what exactly they are being passing the characteristics, they are passing the node name, they are passing the application allocation policy, which is going to allocate the resource, which is basically a compute resource host list, and the storage list which they are going to give. Apart from this, they are going to give the bandwidth, up bandwidth, down bandwidth, and I think I'm missing one parameter over here, and that parameter is rate per MIPS. So this 10 is rate per MIPS, I believe. Upwind, sorry, scheduling interval. So 10 is basically a scheduling interval which is being provided. So you can actually see that there are different kind of parameters that are going to be passed into this particular set of constructors. So what attributes you want to set as per your hypothesis problem statement or whatever you are considering, then you're going to choose all those parameters and initiate this fog device, right? So that's very important component within this particular system. So if this fog device is not there, that means you will not be able to do any kind of what do you call processing into the system. I'm very sorry. I think I'm- I've been speaking for so long. Anyways, so fog device is the very first thing that you start with, right? Then there is a fog broker which is going to be, have its own implementation corresponding to the work. There are fog device characteristics that you are going to define, and this is actually going to define all the cost related stuff, right? So if you go and look into the DCN fog, now I think we are in the state of discussing that how these things are going to get initiated in terms of steps. So if we look at these particular set of statements, they are similar instructions which are being drawn from the cloud sim examples itself. So if you see, we are just initiating the cloud sim based simulation process, right? So that's just the initialization for that. It's not actually starting, but it's initializing the components for that simulation. Then we are drawing the name of the application, which is DCNS, which is basically a string and just a marker, right? Then there's a fog broker which is being created. Now why this fog broker is supposed to be created? They are going to route the applications towards the different fog devices that are going to be generated during the simulation, right? Then we are going to create the application. And why this broker was created, you can simply see over here. The application is going to use the ID of that particular broker so that it can submit back to the broker for the further processing of the modules, right? So once you go inside this particular create application function, you can actually see that app modules are being created, right? So there are 4 app modules which are being created, and then the app edges are being created correspondingly, and you can simply see what sort of tuple they are going to send. So app edges are actually going to define that, okay, what is the name of that particular app edge, where it is going to be working around, what is the requirement for the particular tuple, right? So if I simply give you a definition for this particular part, so you can simply see what is the source, what is the destination, what is the basic periodicity that should be there, what is the tuple length that should be generated, and what is the no network length corresponding to it. I think the second, this one is being used over here. So what is the network length we are going to have, what is the tuple type we are going to have, then direction and the edge type, right? So the edge type is going to resemble that from where it is being originating and where it is going to get connected, right? So these app edges are actually going to define the direction that how that particular system is going to be worked around. This is just similar to what we have seen in this particular example. Let me open that again for you. So for GUI, and we are, sorry, I should run it. So I'm going to open this DCN game. So we know the sensor is going to come towards the motion part, right? So we have, let me get back to the DCN, right? So we have camera, and that camera is going to get to the motion detector, which is there. So I think there are 4, 1, 2, 3, 4. So first one is object detector, motion detector, object tracker, and user interface. So let's say this is a motion detector. So we are talking about this particular sensor that is going to send the tuple or its information to the camera, and then the further processing is going to be done. So next, if you see, the motion detector and the detector is going to talk to each other, and the tuple is up and the app edge is the module type, right? So that means 2 modules are going to talk to each other corresponding to this particular part, and that is going to go through this particular gateway, right? And then we have object detector to the user interface, and that is again edge module type, and object detector and to object tracker, that is again app module type, and the object tracker to the PZ control, that means we are talking about these particular actuators, right? So from where the object tracker to the PZ control with all the parameters, and the app edge is basically a actuator. So this is what we are talking about here, right? So overall, at the end of the day, this particular app edge is going to define that how the routing of your information is going to happen, right? And how the tuples are going to be generated, that is going to be based on these fractional sensitivity or selectivity models, right? So where they are being defined, they are basically defined under this particular API, that is bursty selectivity or fractional selectivity. So they have their own individual properties to take care of. Bursty selectivity model is that whenever a tuple input tuple is being detected, the output tuple will be generated correspondingly. Whereas fractional selectivity is basically depending upon what parameter we have passed on, right? Based on that particular part, whatever the number of input tuples we are going to get, the corresponding number of tuples will be based on this particular multiplier, right? So that is what you get in terms of your tuple receiving and tuple output, right? And then app loops are being generated. That app loop is actually going to tell you that, okay, whenever some information is going to be received at motion detector, can it be sent toward the other application? If it is going to be sent toward the other application modules, then what will be the sequence for that? Okay, because every individual connection has its own latency associated, right? And when you have a latencies associated, then you have to define the path corresponding to that, right? So this is how you define your application with all the set of modules, all the set of edges they are going to have, all the set of tuple generation model, and all the set of routes that tuple can take if some kind of communication happens between the modules. And then once you have the application created, let me bring you back to the main function. Then you are actually going to set that application with the broker ID, and then you are going to further submit it to the further part, that is to the controller section, right? So once the application is created, then you are going to create the fog devices that we have already discussed previously, where just to show you, this is where the fog devices are being created, right? And they are basically for the what do you call, cloud and the proxy part. And one of the best thing which you can do is to set the flag is cloud.setParent is should be set to -1. This makes you the top level fog device as a fog as a cloud configuration, right? So this is not complex in terms of when you look at the code, it might look complex, but once you follow the sequence, you are actually able to track out that, okay, what is happening into this particular code, right? And you only need to design those particular set of scenario as per your requirement, and then things will work out for you. Then because module mapping are supposed to be done and within the fog devices, this is what is the further code corresponding to it. And the controller is actually going to define that, okay, how these particular set of module mappings are going to work around for you. And that controller is going to submit the application, and it uses the module placement mapping and module placement edge words. Now these are the two basic things which are going to define that how the mapping is going to be done for the application. Because if it is edge words, then that means we are talking about any device which are directly connected to the edges, whereas module placement mapping is basically for the intermediate level things. And then you have a time tracker which is going to maintain the complete timeline for all the instances that are going to be there within the simulation. And then the simulation starts and simulation stops. So this is not a big deal in terms of implementation, but the only thing is that you should know that which particular thing comes after what. Okay. So first thing is initializing. Second thing is creating the application and the broker, right? And that broker is supposed to be, uh, you know, um, you supposed to be assigned with the application. Then creating the fog devices, creating the controller, start initiating the module mapping module, right? And then creating the controller correspondingly, and that controller is going to have an application submitted so that they can be hosted on the fog nodes which are closer to the edges, right? Or if it is not uh, closer to the edges, if it is on cloud, then it should be having the module placement mapping with fog device only, and application and module mapping, which we have chosen above at this particular place while creating the mapping of the system. And once we have all set up, then we can initiate the timekeeper, and that is what is going to give you a printing on the console. And then you start the simulation, you stop the simulation, and then you finally print your overall log, right? So that is what is happening in any of the application, any of the example that you can have. So that's the basic example. Now just to give you an idea of all the APIs that we have. So fog org.fog.application contain all the application related models, that is application at the top level, app module, app loop, and app edge at the are basically hierarchy for them. Then the selectivity model, we have already discussed about it. Then there are entities, actuator, fog broker, fog device, fog characteristics, which are supposed to be passed on to the fog device itself. Then physical topology, if you are going to generate it yourself while creating the system. Then sensors, and then tuples, right? After that you have GUI core. So they are basically being used, these are the support classes which are going to be used when you are going to uh, run the GUI mode, right? Then for dialog they have created these set of classes, right? So they are basically for GUI purpose only. And then finally you have an example. So this is what we actually go and run for the GUI purpose. Then the placement, so controller, module mapping, module placement, they are going to work around. So module placement is basically a top level class, it's an abstract class, and it is being included or extended in all the other placement classes, right? And the module mapping is the corresponding independent class. Okay. Then there are policy there by default, the allocation policy for any of the app is going to be default policy. If you are working around with the policy implementation, then you should be looking into this, and look very carefully over here that what class does it extend. It extends the VM allocation policy. So your application modules are basically the extension of the virtual machines, right? So that I just forgot to mention over here for you. So if we go and actually look into the application module class, it is actually extending the Power VM. And if you go and look inside the Power VM, it is extending the VM class, right? So that's the reason why this app module allocation policy is extending the VM allocation policy, right? And basically what happens is that you're actually looking at that, okay, which host is to be allocated to this particular application, right? So that's why this VM allocation policy has been extending, right? So your app module is basically representing the virtual machine to the underlying simulation engine. So that's why the implementation for these overloaded methods are being done. So by default, whatever the function they does for the basic cloud sim, they does it here as well, right? So they are simply adding the app modules to the mapping of the VM IDs, right? And then if you wanted to have a scheduling, right? So once you have the modules allocated, and then they are going to have multiple tuples, right? This is the tuple scheduler that is going to be there. So if you are trying to plan on implementing something which is related to the tuple scheduling, right, individual node, that how it is going to be working out in terms of uh, in terms of execution of the tuple, this is where you should be considering the implementation for the work of that particular scheduler. right? So tuple scheduler is this, and the stream output scheduler is this. So ultimately, it is what it is doing is time shared over booking energy, whereas tuple scheduler is actually been extending the uh, cloudlet scheduler with time shared, right? So they have the similar set of policies which are being implemented, right? Then there is this if you're working with the JSON, then you can use this file, and then comes this util section, right? So it contains a lot of different kind of utility files, specifically the logger, because it is going to give you the printing on the console. And this is JSON to topology. So if you wanted to have any changes corresponding to it, you can work it around over here. If you are working around with the geo coverage and all other stuff, you can do it. Then comes the very important part, that is the fog events. So let me open this for you. So these are some set of the fog events, right? So why I'm discussing this particular part, because every individual fog entity is going to process any of these events which are being implemented. Now where they are being implemented, that is the point. So let me take you back to the entities. I apologize if I'm making it more complex in terms of understanding, but this is something how they are connected, right? If I doesn't tell you that how the basic example is working, I will not be able to tell you that how the connection of this particular fog event is going to happen with the events, right? With the entities. So let's say if you talk about the fog device, right? So fog device is basically responsible for first hosting the applications, right? And then process executing the tuples and updating the power aware or the performance related things. So where all that stuff is happening. So let me take you to one particular function, that is process other events method, right? So if I take you to that particular part, you will be able to see and appreciate that these are some set of events that are being handled by the fog device itself, right? So fog can do a tuple arrival, fog can do launch module, fog can do release operator, sensor joined, send periodic tuple to other modules which are available on the other fog nodes, app submit, update not tuple queues, updates out tuple queue whenever the tuples are finished, are moved from one application module to another application module which are available on different fog devices, or if the tuple is finished, right? So that is again been done over here. Active app update, actuator join, launch module instance, resource management. So all that stuff has been handled by this particular fog device. What stuff has been handled by the actuator? That is again going to be here in the process event method, and you can see tuple arrival is being handled by the actuator, right? So that means there is only one thing the actuator is going to work around. If you go to the sensor, you will be able to see that it is going to QRS. So this is process event. This is going to do a tuple acknowledgement and emit tuple. So these are the two things it is doing, right? Similarly, your I think tuple is not an entity, right? So this is basically extending the cloudlet. So the fog device, your sensor and actuator, they are actually going to process almost all the events of this particular list, right? So they are basically doing the action for you, right? So that's what is being implemented within this particular part. And if in case if you wanted to add your event, you can just simply add one by just copying and pasting the things. So maybe I say copy and paste and do some, let's say, test and base plus 26, because I need to have a unique name for this. And let's say I wanted to have something within my fog device. So I can go back to the fog device, not fog device, because this is something which is related to emit tuple is from the sensor, right? So emit tuple. So I can have the similar kind of thing implemented here, and I can simply say test, right? And I can add anything over this particular place, right? So this is the place where you should be adding your own behavior in case if you want to extend the functionality of your component, right? So that is this is how you will be able to appreciate the extensibility of this particular tool. That okay, there are ways that I can add on the behavior within this particular system. So that is what is my primary purpose to explain in my course, which is available on superbitsacademy.online. Then there are certain configurations. I think module launch configuration. Yeah, a module launch configuration that is going to give you some basic functions only. And there is this timekeeper. Now, this timekeeper is going to get you a lot of kind of resource management stuff. So it actually logs the different set of instances within your console based on what particular entity is doing the stuff, right? So I think that's it. And the last one is the distribution, and this distribution is basically used by the app edges, so that the particular set of tuple can be generated correspondingly, right? So that's what is there in terms of the fog iFogsim related stuff. And this is pretty basic. I think if you know all these things, it's something which you can use to get started with. There are a lot of other things which can be implemented within this particular iFogsim, but I believe this is out of scope right now for this particular webinar, because it's already 1.5 hour we have spent into this. So the other things we can keep for the other set of webinar, which can be scheduled on the later time. So I think the let me just go to my presentation and see if I have covered most of the things. Yeah, so this is the hierarchy which is there. So we have already discussed about the entities. The sim entity is the top level class for that particular for all particular entities that are being there, right? And before I think before going to the queries, I just wanted to pitch in this particular part. I've just I think around 5 o'clock in the evening today, I searched for this thing, scheduling plus iFogsim, right? Since 2019, right? There have been 516 papers which are published around this particular tool. And this is when the documentation is not at all, I would not say not at all, the limited documentation is available for this particular tool. If people start to get to know about this particular tool, like people know about the cup carbon and the MATLAB, so there might be some more implementations corresponding to it. So I think that this is the place where it should be this is the positive thing I think we should be taking up in terms of this particular tool, and start experimenting with this, right? Because until unless we go and experiment with the thing, it is not possible for us to get through the things. Okay, so great. So is my voice is coming? I think Mazhar is not able to hear me. Is it okay? My voice is okay? Yeah, okay. Great. So let me start taking your queries. So let me look into the chat, because people have asked certain queries while I was delivering. So Mazhar was asking about the paper. So I think Madhusmita has already provided. Thank you, Madhusmita, for that. Let's take Sumit's. Okay, Sumit says, "Sir, Java file working, but right, it was done." Right. So Heather says, "I have several questions. First, IFOC can define a distributed cloud computing location at each ISP. Second, what is the difference? What is difference in SDN? Third, the SDN controller is it using?" So, Heather, starting with the very first one, if you're asking that if it can resemble, you're asking about distributed cloud computing located at each ISP. So when I say ISP can be a dedicated fog device, but it cannot be considered as the cloud-based system, right? In in case if you are considering it as a distributed, it is not basically cloud. It's a distributed network where the computing can happen on the intermediate layers, right? So that's the first answer. Second, you have asked is how it is different than SDN. So SDN is basically more into the networking stuff, right? So if in case if you wanted to have the logical network configurations and all that stuff, then CloudSIM SDN works for you, right? It has more implementation. Whereas if you wanted to have the implementation of the IoT based system, then iFog is the one which you should be considering. Then what SDN controller is it using? So by default, by default, it is just using it for the basic networking, right? No specific SDN controller has been defined into this, right? Then Abdul, sir, how can I get recording of this webinar? It is already there on the YouTube. I'm just right now streaming it on the YouTube. So you will find once we finish this lecture, you will find the video over there. I'll be sharing the link uh, after this particular webinar. I'll generally take 2-3 days to send a email where I ask for feedback as well as I send you a thank you note for attending the webinar. Okay, so Asan Siddiqui is asking for mic access. Okay, Asan, unmute yours. Now you can. Now anyone can unmute themselves, but please uh, avoid confusions, right? Uh, Let me just take the questions first on the chat, and then we can have the conversation on the mic.
Good
Then
evening to all of
Mazhar
you.
is saying, because I need to put on my mic for this, on my headphones for this. So let me do it in between. So Mazhar is asking this, sir, how can we provide tasks to the simulation to evaluate the power of our scenario? So power is calculated automatically by the system, right? Once you generate the output, you will be able to get that. But for tasks, you have to work around with the tuples, right? So that is where you can, consider. Some dataset contain 30K or to 100K task details. How to include particular dataset containing, for example. So, Mazhar, when you are working with the sensors are emitting tuples, right? So within that particular part, you can actually include those tasks, and those tasks are basically going to define that, okay, what is the length and what is the bandwidth they are going to take, right? So once you define that through the tuple, it is going to work around for you. There is no issue, right? So I think great. Hope, Mazhar, you got your answers. And I think you can contribute back to the community as well if you have uh, going through the things. Okay, so you want me to show you how to generate the task. Mm, okay, let me check if I can do it quickly, but I can just simply tell you whenever we are creating a sensor, right? Where are the sensors? Entity, within entity we have sensors. Okay, so you can see this is transmit and this is send, right? And generally what happens is the distribution which is going to be done corresponding to the implementation part, it is going to get over here. So the data set which you wanted to include, you can simply either do the working over these particular set of line. You can just simply now, the very first thing is you have to create a text file which is going to give you uh, on each individual line, which is going to give you. Let me show you. Let's say because each tuple is going to have its what do you call the length, right? So let's say I'm having a length of 20,000 for first tuple, and then let's say there is a requirement for bandwidth this for second 1500, and the requirement for this is 36, right? And so on. So whatever the task set you have, right? You can generate like this, and then you can use a file reader over here, right? And then pass it on, or pass it on as a data with the tuple, right? Or you can actually send it uh, to the other part one. Just go to the transmit. So here you can simply see the tuple has been created, right? And in fact, here also you can do that particular stuff. Instead of doing in that particular process event, you can do it over here, and you can start creating the tuples corresponding to each transmit. So you have to have some final, I would not say final, you should have a static variable which should be having a counter for that particular line, right? So that every time a tuple is being generated, uh, we have JSON file containing, great, you can use that particular JSON reader for reading that particular file. So I've actually pinpointed you the place where you can write the code, okay, and then you can work it around. I think there should not be any issue in that. I think you understand it's a live session, and we have a limited time over here, and it's already 10:45 with me. So definitely, maybe we can work it around, but not in this particular session. So anyone who wants to take on the mic, I think which
Yeah,
file needs to be modified according to our scenario?
good evening, sir. With your permission, can I ask one question, one or two question?
Yes, who is there? Can you introduce yourself?
Yeah, my name is Mohammad Hassan Siddiqui. I am
Yes.
from NITTR Chandigarh, sir,
Okay,
and
great.
registered this year for the PhD, sir.
Okay,
I want well wishes from your side, sir.
thank you. Koi.
Sir, my question is that ki whether is it possible in this simulator we can implement our machine learning algorithm like that for the analysis?
So for what purpose you are trying to use this machine learning?
For the smart incorporation of the particular fog node devices.
So I think uh, the primary problem with any of the machine learning part is that you should have a data for training that particular thing, right? So if you have data available, you can
Hmm.
implement that model at any place.
Hmm. So the data will be generated by the which I have already implemented in the GUI form from
Hmm.
the sensor.
Hmm.
So automatically it will be considered from that side.
No, you already have some data which you have used for
Yeah,
training the
yeah.
model. You have
Suppose that we
trained the
have,
model. You have trained the model.
suppose, yeah, yeah. So suppose that we have a data,
Mm-hmm.
raw data generated by the, let's see one example. Suppose that's a temperature sensor we have.
Mm-hmm.
On the basis of that particular raw data, we just want to simulate the machine learning algorithm in the particular iFogsim. Is it possible? For that, we have to, otherwise we have to look into another kind of simulation.
It is possible because a lot of research has been implemented using cloud sim, and people have implemented their machine learning algorithms in that, right?
Okay.
If it is
Thank
possible there, it is possible here as well, right?
you.
Now the point comes is because you wanted to implement it on the sensor, right? That is correct.
In fog node, sir. In fog node.
So in fog node, if you are trying to implement it, and if it is on the basis of the data which is coming out from the sensor, and you have already trained that particular model, then it is possible. And for that
Okay.
particular part, you should be implementing it inside the fog device, and that should be done under tuple arrival.
Hmm. Okay.
Okay, so this should be the primary method where you should be, considering for implementing your machine learning part.
Mhm. So, whether is it possible in this particular simulator that the mobility of the particular sensor or the node will be considered in this simulation?
So that means you are considering the a sensor is going to disconnect from one fog, and then it is going to connect to the another fog, right?
It may be, but it is not in the stationary condition, but is in mobility condition.
So if it is considered only for the connected node, right? And if you are considering your sensor is moving, then there is no issue, right? But if you are considering that the sensor detaches from a fog node and then go and connect to the another fog node, it's not possible right now.
Hmm.
If you wanted
Thank
to
you.
have that, you have to write your own code. Like, just I have
Hmm.
displayed you one of the way that you can create an event and then you can implement it, right? Then you have to do
Hmm.
that handoff kind of thing. Okay.
Thank you so much for your sir, knowledgeable presentation here.
Right. I hope the things we you wanted to ask is clear, right?
Yes, sir. Is it somewhat clear? When I will try my best, it will be possible for me that in future nearby, it
Mhm.
may be easy for me that.
Okay, so cool. Right. So Mazhar is asking another one: which file needs to modify according to our scenario? So Mazhar, I already told you the sensor file you should be looking into, right? Specifically, the transmit function you should be considering for your particular work. Internet is deficient of iFogsim and sFogsim details. Would you please suggest us where to find related information? Mazhar, best place to find about iFogsim is the paper, the core paper, right? So every time you go and read that particular paper, you will definitely get a new information, right? I myself read it around 15, 20 times. Even before preparing for this particular webinar, I went back to that paper, I read it again, and I was able to, correlate some new things from that particular paper. May we share our email address to for the correspondence later? I think I can share it right now. Hello@superwits.com. Right. This is where you can actually correspond with me, right? And I think Wazir, you have already access to my course, right? So a couple of things I've already explained in that. I hope you got it from there. So anyone else have some questions? Okay. Any other questions people have for me? In case if you are out of questions, so I think I can come to this resource tab. So generally, I post blog articles. These days, I'm just updating the articles. I'm not exactly posting new articles, but updating the existing articles. So I'm writing on cloudstemtutorials.online. You can find my courses for subscription on superwitsacademy.online. They are on-demand, self-paced courses, and they are quite nominal in terms of subscription fee. And you can reach me out on hello@superwits.com. Generally, I take 2-3 days to respond back because of my engagement in my current uh, work. But anyways, just I go and reply to the emails even if it takes 4 or 5 days also. So you can write me on hello@superwits.com, and that is what I have. So okay, Mazhar, I'm glad you have got something out of that particular course. Uh, so please make webinar on load balancing, Rajeshwari ji. Definitely, I'm going to have that. In fact, I'm working on some restructuring of my CloudSim course. I'm going to do some additions to both the courses, and they will be very specific to the topics and use cases, right? So I'm considering that particular part. uh, okay, so Mazhar wants to communicate with with the gentleman who is working on the machine learning. So I think you can connect with each other. You can simply choose the name. I think uh, this is, I believe, is Hasan Siddiqui ji, right? So he is the one who is working on the machine learning. So you can share your contacts if you wanted to collaborate. I have no issues. In chat, you can write for that. Okay. So Abdul Nasir, thank you very much, sir. Thank you, Abdul, for your kind words. Thank you, Rajesh, for your kind words. Heather, machine learning webinar when, sir? Heather, I have been occupied with my work a lot, and in fact, last week I was not well for 4 or 5 days. I was down with fever, so I had plans in rolling out machine learning track last week, but it got delayed by 1 more week. So if you have registered for the machine learning series, I'll be mailing you in 2 3 days about the particular track. So thank you very much for your patience till now. But yes, I'll definitely going to have that. Okay, so I think Mazhar has shared his email address. Anyone who wants to collaborate with him on machine learning at iFogsim, you can actually connect with him. So Abdul, you can actually go to www.superwitsacademy.online and you can just go through both the courses. Whichever you find is suitable, you can subscribe to that. Sone, thank you very much for your kind words. I hope this webinar is going to be more helpful for you. The recording will be available on my YouTube channel, which is Superwits Academy. You can go through that. uh, Asanji, what you can do is you can go to my YouTube channel, that is Superwits Academy, and you can find for my machine learning introduction webinar, right? So it is available there. So you can go through that webinar first, and at the end you will be able to find the link where you can go and register. I think I can share that link over here. So get started with, this is the basic webinar which I did. You can go through this and then at the end you can register on that link. Okay, any more questions we have? I think we have spent almost more than almost close to 2 hours. We started at 9 as per my time zone and it's already 11. So I think we should wind up. If you have any more questions, I wait for another 2 minutes. Otherwise, uh, thank you very much for joining in. It's like, you people are great. You have patient to listen me for 2 hours. There are still 14 people on this call, and I appreciate, like, attending any lecture for 2 hours is quite cumbersome. So I hope this webinar is going to help you out in some way. Yeah, Abdul, it is much needed lecture. And I sincerely apologize. I actually postponed it twice. So I look forward for your feedback. I'll be sending an email maybe tomorrow or day after tomorrow. It will contain the link uh, uh, to the feedback form as well as the recording of this particular session. You can go through that on your own time. And please do share me the feedback so that I should be able to improve upon for the upcoming webinars. So I think we are done with our questions and queries and everything. So thank you very much for joining in, and I hope this is going to get you some benefit. And let's meet in another webinar. I'll be announcing it. And because of work, I have to restrict myself for one webinar in a month. So I hope you will be able to understand. And I should mention thank you very much for your support throughout since I've started it, and I think January 1st. So we were able to pull out around 6, 7 webinars till date. So I'll try to maintain the pace. At least one webinar will be there. I'll try to get to two, but because of my work commitments, it is getting quite difficult for me to get the time for the preparation for such kind of webinars. So hopefully it will be there. But anyways, definitely we have one at least one webinar, and I'm also planning to have uh, a one-to-one internship, right? So if I'm working on the documentation, once it is done, I'll be sharing with you guys, and we'll be asking for the feedback. So hope you will be, helping me out in that. Okay, Sony is asking, do you have task scheduling with iFogsim simulation toolkit like the one with the cloud sim? I mean, on the website. Not yet. I'm working on that particular part. There are few refinements which are supposed to be done. Once it is available, I'll let you know. So if you are already on cloud sim course, I'll be sending an email newsletter. Otherwise, uh, I can directly send it to you. You can just simply email me on hello@superwits.com, so that it should be in the queue. And I'll be able to send you across once the things are done. All right then. So thank you very much for joining into this session, and it's almost 2 hours 9 minutes for us in this particular part. So great. See you all. Good night, and good afternoon, good evening, as per your respective time zones, and see you in the